My friends, welcome to HabashaTube. In this step-by-step YouTube video tutorial, we are going to study about linear constant coefficient difference equation. After completing this YouTube video tutorial, the learner knows about difference equation, recursive discrete time system, and non-recursive discrete time system. So, difference equation, continuous time signals are characterized by differential equation, whereas discrete time signals are characterized by difference equation. An important subclass of linear time invariant system consists of those systems for which the input signal is x of n and the output signal is y of n, and it satisfies the nth order linear constant coefficient difference equation. So the general form of the difference equation is given by a naught y of n plus a1 y of n minus 1 plus a n minus 1 y of n minus n plus 1 plus a n y of n minus n is equal to b naught x of n plus b1 x of n minus 1 plus bm x of n minus n. And this can be generalized as summation k starts from 0 up to n ak y of n minus k is equal to summation k starts from 0 up to m bk x of n minus k, where ak is coefficient of y of n and bk is coefficient of x of n, and this can be generalized as y of n is equal to 1 over a naught summation k starts from 0 up to m bk x of n minus k minus k starts from 1 up to n ak y of n minus k. And the initial conditions are y of minus n, y of minus n plus 1, y of minus 1. These are the initial conditions. Now let's go to recursive and non-recursive discrete time system. A discrete time system is said to be recursive if it is dependent on present as well as past inputs, and if it is dependent on past outputs. The output of causal recursive system can be expressed in general as a function of y of n minus 1, y of n minus 2, y of n minus n, and x of n minus 1, x of n minus n. Therefore, the present output is dependent upon past output and present as well as past inputs in the case of recursive discrete time system. In contrast, for non-recursive discrete time system, it is dependent present as well as past inputs only, but is not dependent on past output. So this is the signal flow graph of the difference equation. So this is for a recursive system. So it is dependent on present input and past inputs, as well as it is dependent on past outputs also. Had it been this block is absent, it will be non-recursive discrete time system. So an example for this non-recursive system is the convolution y of n, which is equal to k start from 0 up to n h of k x of n minus k. This system is causal system as well as it is non-recursive. It is not dependent on past output parameters. The other one is recursive discrete time system. This recursive discrete time system is dependent present as well as past input, and it is also dependent on past output parameter. Now let's consider a discrete time system which is described by the following difference equation, and let's solve this one recursively. Let's consider a discrete time system which is described by the following difference equation: y of n minus 3 over 2 y of n minus 1 plus 1 over 2 y of n minus 2, which is equal to x of n, where x of n is 1 over 4 raised to n u of n is an exponential discrete time sequence, and it is defined for 0 less than or equal to n is less than or equal to 5, or just you can represent x of n as 1 over 4, 1 over 16, 1 over 64, 1024. And the initial condition is given by y of minus 1 is 4 and y of minus 2 is 10. So at n is equal to 0, substitute n is equal to 0 on the previous equation here. Y of 0 minus 3 over 2, y of 0 minus 1 plus 1 over 2, y of 0 minus 2 is equal to x of 0. Y of 0 minus 3 over 2, y of minus 1 plus half of y of minus 2 is equal to x of 0, but the value of x of 0 is 1. Y of 0 from this is equal to 1 plus 3 over 2 times y of minus 1 is 4 minus half multiplied by y of minus 2 is 10. When you solve this, just you'll get y of 0 is equal to 1 plus 6 minus 5. Y of 0 is equal to 2. Similarly, for n is equal to 1, y of 1 is equal, substitute n is equal to 1 on the previous equation. Y of 1 minus 3 over 2, y of 1 minus 1 plus half of y of 1 minus 2 is equal to x of 1. Y of 1 minus 3 over 2, y of 0 plus half y of minus 1 is equal to x of 1, which is equal to 1 over 4. From this, y of 1 is equal to 1 over 4 plus 3 over 2 multiplied by 2 minus 1 over 2 multiplied by 4. So when you solve this equation, you'll get y of 1 is equal to 1 over 4 plus 3 minus 2, which is equal to 1.25. In a similar manner, when you solve for y of 2, you'll get 0.9375, y of 3, 0.7969, y of 4, 0.7365, y of 5, 0.6982. And using MATLAB, just we can solve like this. Enter the coefficient of x of n. The coefficient for x of n is 1. The coefficient for y of n is 1 minus 3 over 2 and half. Enter the initial condition. The initial condition is 4 and n. Enter the sample sequence, input sequence x of n. 1, 1 over 4, 1 over 16, 1 over 64, 100, 1 over 256, 1 over 1024. Therefore, the output becomes 2, 1.5, 0.9375, 0.7969, 0.7305, 0.6982, which is identical to the previous values. And the graph for the input sequence is x of n, which is equal to 1 over 4 raised to n. 1 over 4, the power of 0 is 1. And the output sequence y of n is, the first value is 2, and the second value is 1.5. The third value is 0.9375. The fourth value 0.7969. And the last value is 0.6982. Function definition to solve the given difference equation. Function, the output arguments are y and n, and the name of the function is t. The arguments are b, a, y naught, and x. Here, y is output discrete time sequence, x input discrete time sequence, y naught the initial condition, a coefficients of y of n, b coefficients of x of n. Compute the initial condition for the filter using filter IC function. Z is equal to filter IC b, a, y naught. Compute the output parameter y of n using filter function. Y is equal to filter b, a, x, z. N is equal to 0 up to length of x minus 1 and end of the function. Now let's go to the function calling part. Function calling, clear all, close all CLC. Step 1, accept the difference equation coefficients a, b, and y naught from the keyboard. B is equal to input enter the coefficient of x of n, a equals input enter the coefficient of y of n, y naught input enter the initial condition. Step 2, accept the discrete time input sequence samples x of n. X is equal to input enter the sample sequence x of n. Now the next step is to compute the output discrete time sequence y of n, y, n. So this is a function calling part. Y, n is equal to de, which is function name, b, a, y naught, x. Next step, display the output discrete time sequence. The output discrete time sequence y of n is disp y. And the next part is to plot the input discrete time sequence. The next part is to plot the input discrete time sequence. Figure 1, stem n, x, red color line with Z3, and the title is input discrete time sequence x of n, which is equal to 1 over 4 the power of n, and the font size is 10.6. X label is n index, y label is the amplitude, axis type, and grid on. Figure 2, stem n, y, red color, the line with Z3. The title is output discrete time sequence y of n. X label is n index, y label is amplitude, axis type, grid on.